there, this is Dr. Mu'in Hasib again with lesson 2 on individualized quality control plan, IQCP made simple. In lesson 1, if you recall, I gave you a brief quality control history, and I covered the topics: what is IQCP, what are the rationale for moving to IQCP, why do you need IQCP in your laboratory, what are the CAB requirements for an IQCP. In lesson 2, in this lesson, I'm gonna talk about what are the elements of an IQCP, and we're gonna start talking about how to implement or develop these elements of the IQCP. And in lesson 3, I will continue with how do you implement or develop the elements of an IQCP, and I will tell you where to begin and a subject summary. What are the elements of an IQCP? IQCP consists of 3 key elements: risk assessment, quality control plan, and quality assessment. IQCP equal risk assessment, quality control plan, plus quality assessment. Now, how do you implement or develop the IQCP plan? I need you to remember 353, 353, because these are the mandatory components of the IQCP that need to be evaluated. You have the first 3 is the 3 mandatory sections or elements of the IQCP plan, which is the risk assessment, quality control plan, and quality assessment. Each one of these 3, okay, the elements of the IQCP need to be evaluated using the 5 mandatory areas, which are specimen, test system, reagent, environment, and testing processes. So that's the first 3, and this is the 5, and the last 3, the other 3 is 3 you need to evaluate them going through the 3 mandatory phases of testing: the pre-analytical phase, analytical phase, and post-analytical phase. So 3 mandatory elements. Each one of them you're gonna need to evaluate using the 5 mandatory areas, and you need to cover the 3 mandatory phases of testing: pre-analytical, analytical, and post-analytical. 3, 5, 3. So we're gonna start talking about these 3 elements one by one. We're gonna start with risk assessment, RA. But first, what is risk? Risk is a future event which may result in process failure. In the laboratory, it is those instances that may lead to errors that would harm patients. These must be identified and reduced as applicable. Now, risk assessment, the identification and evaluation of potential failures and sources of errors in a testing process. So we said each one of the IQCP element must be evaluated using the 5 required components in the 3 stages of testing: pre-analytical, analytical, and post-analytical. So we're gonna evaluate the risk assessment using the 5 required components: specimen, test system, reagent, environment, and testing personnel, which also we said must include the 3 phases of testing: pre-analytical, analytical, and post-analytical. So we start with the specimen. Okay. Evaluating the specimen as far as and the risk assessment for the specimen, include the following. You need to look at patient preparation, specimen collection, specimen labeling, specimen storage, specimen preservation and stability, specimen transportation, specimen processing testing, specimen acceptability and rejection, and specimen referral. The next item on the list is test systems, which includes inadequate sampling, clot detection capabilities, detection of interfering substances like hemolysis, calibration associated issues, failure of system control and function checks, and under that you need to look for built-in procedure and electronic controls, external or internal liquid quality control, temperature monitors and controls, and then you need to look at mechanical electronic failure of the test system options, optics, and under that you need to look at the pipettes, barcode readers, software, hardware, and data transmission. Then we move on to the next required element, which is the environment. And under the environment, you need to look at the temperature, ventilations, lighting, noise and vibration, humidity, adequate space, altitude, dust, water, statistic discharge, and utilities. Next item on the list is reagent, and under reagent you need to include and assess the shipping receiving conditions, storage conditions, expiration date may differ based on storage requirement, preparation instructions and requirements. Next, you need to look at testing personnel, and under that you need to assess the appropriate education and experience or qualification of the staff. Need to look at license or certification required, training, competency, and adequate staffing. So to summarize the 5 required elements of the risk assessment, okay, for a specimen, you need to look at patient preparation, collection, labeling, storage, preservation, stability, transportation, processing, acceptability, and referral. For test system, you need to look at inadequate sampling, clot detection, detecting interferencing substances, calibration issues, mechanical electronic failure, optics, pipettes, barcode reader, function checks, built-in controls, external controls, temperature monitoring controls, software, hardware, transmission of data LIS, and result reporting. Under reagent, you need to look at shipping, receiving, storage, expiration date, and preparation. Under environment, look at temperature, humidity, dust, water, utilities, and space. Under testing personnel, you need to look at education, qualification, experience, training, competency, and adequate staffing. And this is just a table with the requirements and what do you need to verify under or assess under each one of them, which I already told you about. Next, as you review the previous list, you need to ask yourself, what are the chances of this error happening? Is there a step in the process that help reduce the chance of an error? And this is basically what lean is all about, lean concept. You need to reduce or remove the unnecessary steps or the things that cause you issues or delays. If not, how do I minimize or reduce the likelihood that this error could occur anywhere in the testing process? Evaluate the frequency occurrence of those failure or errors. Evaluate the impact, potential harm due to those failures or errors. The resulting risk assessment is then used to develop the quality control plan, how you will control these risks, which will explain how will you control these risks. So after you do your risk assessment using these 5 mandatory elements I talk about, then you move on to develop your quality control plan, QCP. Tools for conducting the risk assessment, you could use table or grids or the fishbone diagram, which we are going to use. I'm going to show you an example of it on the next slide. Process flow diagrams, bullets or symbol listing, paragraph format, highlighting or underlining in the manufacturer instructions. So this is the fishbone diagram for the risk assessment, identification of potential failure. As you can see, we are assessing the 5 things: specimen, testing personnel, environment, reagent, and test system to find the any potential failure of any of these items under each one of these components to eliminate or reduce or to prevent from rehappening. So where can I find resources for information for conducting a risk assessment? In your laboratory policies and procedures, instrument manual, troubleshooting guides or records, manufacturer package insert, also manufacturer alerts and bulletins, verification or establishment of performance specification, testing personnel qualification, QC data, current or historic, calibration data, PT data, quality assurance information, including corrective action, scientific publications, record of incidents or complaints, OVRs, regulatory and accreditation requirement, test process flow charts or maps, other information as appropriate and needed. I am done with the second lesson on IQCP made simple. To continue with the subject, please go to lesson 3, where we will continue with the topic, how do you implement or develop the elements of IQCP, and then also I will teach you where to begin in your IQCP process and a subject summary. Thank you for watching.